Okay, as I mentioned before, this is was a very commonly missed problem, even though the solution to it isn't that complicated. A minimal number, they're talking about the sum of its digits is equal to the product of its digits. And it's very easy to begin by testing out some numbers and noticing if you just tried to use 5 2s, so 5 really small numbers, when you multiply those together, you get a product of 32 versus a sum of 10. So it becomes very clear that you're going to need to use some ones, and probably multiple ones, to get your answer there. So the first thing I thought about was, can I use 5 ones? Well, clearly you can't do 5 ones because 5 ones added together gives you 5, and they multiply together give you 1. So I started thinking about ways. Is it possible to use 4 ones and then a number? And the answer is no, because anything times 1 is itself, but you're adding 4 to itself, and so the sum is never going to equal the product in that case. So now I've really narrowed the field down to where I either need to have 1 1, 2 1, or 3 ones, and it makes it a lot easier to go through and decide. Well, if I've got 3 ones, that already has a 3, and so I could start thinking about, I know I'm going to have to use small digits, so the first thing I could try is 2 and 2. Well, 2 times 2 is 4. That doesn't work. I could try 2 and 3. 2 times 3 is 6, but the sum is 8. So the next thing you would try is 3 times 3, and there you go. You have your first amenable number. Now, once you find an amenable number, you have to find out how many permutations of that number are there. Well, in this case, trying to do that is just like solving the problem, how many ways can you arrange the letters in the word number, or in the word Mississippi? And so in this case, there are 5 numbers, so you do 5 factorial over 3 factorial, 2 factorial, which just equals 10. So there are 10 ways to arrange the numbers, digits, 3 1s and 2 3s. Now, looking ahead a little bit with the 3 1s, if you tried 3 4 or anything with numbers bigger than 2s and 3s, it gets too big really quick. So that's the only one you got with 3 1s. So then I considered looking at 2 1s. Well, the smallest possibility for 2 1s is putting 3 2s down. Bam! All of a sudden you find another one that works, because 2 times 2 times 2 is 8, and you end up with 8 when you do the sum of those. And so again, that one is just like this, except that you're 3 2s and 2 1s, and so there are 10 of those. I wanted to see if I had any others with 2, and as I'm here looking at them, and I'm unable to see any others that worked. Now, when I first did this, that's what I ended up with as 20, because nothing else worked. Once I put a 3 in this one, it went bad, and it didn't work. And so I needed to try to find another one, and what I finally realized I did wrong is that when I was looking at the 3 1s, I forgot one, and that is 2 and 5. I really didn't think there was any way that a 5 could be in one, but then as I was looking at them, I realized 2 times 5 is just 10, so I guess I could have a 5, and then when I went and looked at it, it did work. And so 1 1 1 2 5 is your third case, which was probably the hardest one to come up with. It was pretty easy to come up with these 2, and so when you do this case, it's just going to be 5 factorial over 3 factorial, because the 2 and the 5 are not a repeat, and so that just equals 20. Add up the cases, and you get 40.